Hi guys, so welcome to another video in which we will be discussing nuclear dimensions. So in the previous video we have just gone over the Rutherford scattering experiment. Now in order to investigate nuclear dimensions, there is one interesting thing that you should know about. So in the Rutherford scattering equation, he was assuming that the size of the target nucleus, the size of the target nucleus S was small compared to the distance r that an alpha particle approaches. So this is your alpha particle. So that an alpha particle approaches before it gets deflected. To repeat it once again, so in the Rutherford's scattering equation, Rutherford was basically assuming that the size of the nucleus, the target nucleus, was always small compared to the distance r that alpha particle approaches before it is deflected into another direction. So therefore we can assume that the Rutherford scattering experiment gives us a way to find the upper limit to nuclear dimensions. Now let us see what was the smallest value of r. Let me draw it again over here. So this is my nucleus, this is my atom, this is my r, this is my alpha particle. So in this video we will be basically trying to determine the smallest value of r to which alpha particles approached in early experiments. Now the smallest r value will always be at 180 degrees when the particle approaches the nucleus head on. So at the instance of the closest approach, one thing that you need to keep in mind is that all of the initial kinetic energy is going to be transferred into the potential energy. So once that happens, we will be easily able to manipulate the formula for the initial kinetic energy in order to find out our closest distance of closest approach. Now the formula for the initial kinetic energy looks somewhat like this. The initial kinetic energy, note that all of it has been transferred into the potential energy. So it is going to be 2ze square over r and 4 pi e naught. Now I need to work out the distance r. For that you must know these. Wait a minute. Now let me first readjust it and then I'll provide you some values which we already know that will help you to find the distance of closest approach. So to find the distance of closest approach, I will make r the subject. I will take kinetic energy in the denominator, and now I will be good to go. So let me just locate an important image from here that is going to help you guys realize this. So yeah. Now the maximum kinetic energy in alpha particles of natural origin is known to be 7.7 milli electron volts. Now you have to convert the milli electron volts into joules and you know what you do with 1.6 into 10 minus 19 coulombs in this case. So once you are done converting the milli electron volts into joules, you get 1.2 into 10 raised to power minus 12 joules. And 1 over 4 pi e naught has this value. Now you can simply substitute everything into this equation, including Z. Z is basically going to be the atomic number of the metallic foil, of the atoms of the metallic foil. In this case it was gold, and gold has an atomic number of 79. So all of that would be substituted into this equation, and the closest distance of closest approach is going to be 3 into 10 raised to power minus 14. So I hope this video was helpful, and let me know if you guys want more videos like that. Let me just go over, if you've already understood it, you can simply just pause the video or go and watch any other video that is helpful to you. But let me just go over all of this once again so that the concept is stored very well in your mind. So what I explained was that when your alpha particle approaches the nucleus head on at 180 degrees, all of the kinetic energy is transferred into the potential energy, and we have the formula for that: 2z e square over 4 pi e naught over e naught into r. So we simply readjust the formula. We take kinetic energy into the denominator, we take r into the place of the kinetic energy, and we get something like this. And here we have your kinetic energy, right? So we know that the kinetic energy of alpha particles of natural origin has a maximum value of 7.7 milli electron volts, which can be converted into 1.2 into 10 raised to power minus 12. We know the value of 1 over 4 pi e naught, and we also know the atomic number of the atom in discussion here. So we know this, we know this, we know this, and we know this. We'll plot all of these values and we'll find the distance of the closest approach.